slide. We have that. So their advisor is Mr. Jonathan Comfort. Okay. And Mr. Ian Franco Lori.
Hello everyone, I'm Kyle Fillion. Brian Muter. Luke Kaplan. I'm Ben Zarud.
I'm Tingman.
Joseph Casabia.
Karina Carlos.
Michael Bingo. Delaware.
Joseph Schaller.
And we are the founding members of Cal Poly Bronco, or CPB Consulting, a consulting firm created for our senior project. Today we'll be presenting the Rancho California Road Roundabout Improvement Project. Just to take you through the outline, we're going to go through the project background, scope, and intersection analysis, followed by roundabout roadway design, siding and striping, and project drainage. Then we'll go through the maintenance of traffic and end with our cost estimate and specifications. Our project is located just outside the city of Temecula in Riverside County, California. It involves the Rancho California Road corridor, shown in green, and the study intersections, shown in red, of Los Reynaway, Calle Contento, Monte de Oro Road, and Columbus Road. The scope of this project was the planning and design of a single-lane yield-controlled roundabout at one of the study intersections. This began with the traffic impact study, which I'll go into detail about later. Including the traffic impact study was an intersection control evaluation and pavement design, both using Caltrans methodology. Once we had our intersection chosen, we took the intersection to preliminary design, including a drainage report and a script plot of our alignments. We then ended with final design, including PSC, which is plans, specifications, and estimate for our project. As I stated earlier, we conducted a traffic impact study in accordance with Riverside County. In a scoping agreement form, which was approved by the county, we identified the Wine Country Community Plan as our build-out model. This model takes into account land use and roadway changes for build-out year 2035 while keeping the unique rural and aesthetic characteristics of the wine country area in mind. Base year turning movement counts were provided for the peak hour for AM, PM weekday, and PM weekday conditions. Also provided were model plots which identified roadway information such as roadway classification and daily traffic on the base and build-out years in the form of average daily traffic, or ADTs. Build-out year traffic was initially gotten by the iterative method identified in the National Cooperative Highway Research Program Report 255, which uses the build-out year ADTs and model ADTs shown in orange and the existing turning movement counts in blue to yield the estimated turning movement counts for the build-out year. However, we chose to instead use the turning movement counts directly from the Wine Country Community Plan because, as I stated earlier, it better reflects the wine country area. This can be seen in that the Wine Country Community Plan identifies, it uses an updated trip generation, which includes winery hopping, which is when people visit more than one winery at a time, which is common to the area and pretty much only the area. It also includes an updated land use and roadway information on the area for the build-out year. Intersection analysis was done primarily using Sidra intersection, although Synchro Studio 8 and Rodel, a program based out of the United Kingdom, were used. Intersections were analyzed using intersection delay and level of service. Level of service is a letter-based classification based on the roadway's congestion levels. These levels of service were analyzed using the 2010 version of the Highway Capacity Manual. As I stated earlier, we also conducted an intersection control evaluation for Caltrans Policy Directive 1302. This wasn't required for our project, but we wanted to verify the Wine Country Community Plan's vision of a roundabouts at all the intersections along the corridor. We analyzed the intersections according to signalized control and yield control roundabouts because the intersections are under existing stop control and they all need mitigation. County requirements and requirements outlined in the Wine Country Community Plan require that level of service be C or better for all intersections. Lastly, we conducted a pavement design according to the truck traffic, which was included in our turning movement counts. This was done using the Caltrans Highway Design Manuals, chapters 600 through 660. Truck traffic was converted to equivalent 18,000-pound single axle loads or easels, which in turn were used to calculate traffic indexes for the pavement locations. These were used with gravel equivalencies and gravel factors to determine the thickness of the asphalt, concrete, and crushed aggregate base layers of the roadway design. The The results from the traffic impact study are shown below. These were obtained using the Sidra intersection and represent the build-out year of 2035. As you can see, the intersections of Los Serene Way and Monte de Oro Road have very high delays in the existing conditions and would require dual-lane roundabouts for mitigation. On the other end of the spectrum, Glen Oaks Road only has a level of service of C, which does not require mitigation for the county or one country community. For these reasons, CPB Consulting has chosen Calle Contento and Rancho California Road as the intersection to bring to design. This will be a single-lane, yield-controlled roundabout which will adhere to the Wine Country Community Plan and all relevant design standards. Also, because the project is less than a mile from the Anza Road roundabout, which was constructed in 2012, driver comfort is expected to be high. This roundabout will provide a level of service of C or better, which adheres to both the Wine Country Community Plan as well as Riverside County standards. I'll now pass it off to Brian for roadway design.
All right, so the first thing is our standards that we use in the roadway design. We reference quite a few different standards, but primarily we use for basic roadway geometry, chapter 200 of the Highway Design Manual. And then for roadway specific design, we use the National Cooperative Higher Research Program Report 672, Information Guide on Roundabouts. This is the document that FHWA standards reference, that various state DOT standards reference. This is a big document on roundabouts. And then for our plans, we're Riverside County, so we're going to call their standards. But before we can do plans, we're going to do preliminary design, which includes horizontal and vertical alignments and the basic roundabout parameters. For our horizontal and vertical alignments, we had a couple of constraints, major constraints, which were the grade and the design speed. You can see the incoming grade of the south leg of Calle Contento is 7%. That is greater than the Riverside County max of 6%, and the NCHRP recommended maximum for roundabouts of 4%. Also, design speed, Rancho California Road is 55 miles an hour. So our final solution is to offset it to the northwest. Before we can get there, we have a couple of iterations. Our first idea was to keep the roundabout on the existing road without moving it anywhere, but we could not meet grade. In order to meet that 4% incoming minimum and the 6%, to get a 6% maximum before that, we had to raise the roundabout about 11 feet, which of course is not feasible. So we then offset it to the northwest. This initial offset design, however, had some issues because we created large sweeping curves in order to meet the design speed of 55 miles an hour. So the whole road, Caltrans gives a table which compares design speed with the curve radius. So that's what we use for that. However, that took a lot of right-of-way there. This spot, this caused our preliminary cost to be very, very large. So here are the profiles for that first iteration of the offset design. We are only 5 feet above existing ground, which is still quite a bit. This was also because our initial design, we're trying to keep everything in line. The roundabout is tilted. This is because we were thinking that we needed a smooth transition into the roundabout. However, these are centerline profiles. These are not what the vehicle will actually be traveling. So our final design will take that into account. So here is our final horizontal design. The approach legs are tightened up so we save on right-of-way cost. Also, these legs are designed so as to slow traffic down as they enter into the roundabout, because the roundabout design speed itself is 25 miles an hour. Then here are the profiles for our final design. We're only about a foot above existing grade, and you can see I don't know how easy it is to see, there's a grade break coming into the roundabout. However, as I said, the actual lane will not travel that. There will be room to create a smooth transition into the circular roadway. Now, the main roundabout parameter itself that defines a roundabout is the inner diameter. This is the inscribed diameter, This is the diameter of the circle from outer curve to outer curve of the roundabout. Here is a table from the NCHRP that gives values. Ours is a single lane roundabout, and our design vehicle is a WB62. So that gives our range, and then auto turn analysis revealed that narrowed this inner diameter, inscribed diameter down to 150 feet. Here is our auto turn video showing our final auto turn analysis that WB62 can maneuver through our design. having established preliminary design, we could move on to plan production. We did 4 sets of plans. We did street improvement plans, we did signing and striping, drainage, and then maintenance and traffic regulation plans. This whole process, in this process, we also did quality assurance, quality control process where we had our plans checked and redlined by personnel from the Riverside County Flood who came in. That was very kind of them. So they marked them all up for us, made quite a few mistakes, and we addressed them all. So, street improvement plans specifically, these are the plans that tell the contractor what to build. Specifically, as we zoom into the construction notes, they tell the contractor exactly to build this item here. For example, number 16, construct a ramp in Splitter Island. For this detail on the left, tells them how to build it, and on the right you'll see that's from Anderson, that's what it will look like when it's built. Secondly, our street improvement plans do not have profiles. This is because, as I said before, the centerline profile doesn't provide that much useful information. The centerline is only here, whereas the actual roadway, the edge of pavement lines, and the curb lines are not parallel to that. There's no standard typical section along the roadway. So we call out the elevations at specific important points for the geometry for the contractor. And finally, we have curve data tables, which give more information on the geometry of our design. Here is a video from our traffic study program that shows a representation of the roundabout, our proposed roundabout. On the left is the driver's view, on the right is the corresponding plan view as the driver maneuvers through our new program. Now I'll hand it off to Jen for science.
Now I'm going to talk about our signing and striping plans. At first, when we approached the project, we have an idea of using in-pavement warning lights and also inside warning lights to add additional safety to the intersection. However, those lights don't fit to the wide country theme. Therefore, we only use high visible continental crosswalk. We also wanted to have a ramp on our roundabout. However, when we have our site visits to exit roundabout, the one that next to our project, we saw a lot of gathering sedimentation there. Therefore, we only decide to use the local. We use California and UTCD standard to guide us in signing and striping. This is how we do our signing for roundabout sensor. As the vehicle go into the roundabout, we have our U sign as well as the U marking on the route. We also have the pedestrian sign and diagonal arrow near the crosswalk, especially right here. We have our custom size. This custom size gives the sizes have 2 options. They either use a manual to go into the roundabout as a vehicle, or they can dismount and walk on the sidewalk. And in the roundabout, we have several sizes. These several sizes have to guide the vehicle go through the roundabout. Nextly, our roundabout sensor striping. Most of our striping is follow Caltrans standard plans. Nextly, for Rancho California road west and east approach. For these approaches, we have roundabout warning signs as well as 25-mile advisor speed. We also have street sign and the keep right signs to have the vehicle gradually decrease their speed from 55 miles per hour to 25 miles per hour. We add one construction note here. To the construction notes will say we will install a new like 2 new signs, one for widening roads, warning signs, and advisor speed 35 miles per hour from this station, 500 feet to the west, and offset down like 30 feet. And we do the same thing with the east approaches. For Cadillac Continental, north and south approach, we use the same idea. We keep the same idea when we doing the striping and signing plans. Here we have our widening road warning signs to warn the vehicle there's a curve ahead. This is the example of our signing and marking. We have dot widening extension in detail. We have crosswalk in detail, as well as we have U marking in detail. The material that we use for signing and marking is thermoplastic material. And lastly, EL size example, we have U size, 7 size, and our custom sign. For this custom sign, get the approval from Federal Highway Administration. And Kaohsiung also needs to approve for our site so that us can use this custom site. And for this getting approved process, we already sent our proposal to CPCDC, and we are waiting for them to respond our proposal. And finally, this is our example to install site. Use site into the route. We use 2 by 2 inches telespa steel, and the clearance is 7 feet from the bottom of the use site to the route. And next, I'm going to pass to Joseph for drainage.
Okay, our site lies within the Santa Margarita watershed. Majority of the site here is classified as soils type A, which is highly permeable according to the U.S. Geological Survey. There are 3 existing swells at our site, the northeast swell being the largest at 1,400 feet. Each of the swells have a side slope of 2 to 1 and a longitudinal slope of either 1 or 2%. Here's a picture of the location of the existing swells. Our watershed boundary covers the impervious surface up to where the curves end at each leg. Here's a picture of our pipe and inlet layout. The blue arrows show the direction at which water will flow throughout our roundabout. Using high-density polyethylene pipes, we're able to direct all our water toward the north leg of Pi Contento where our main inlet is located. We've also added 2 swells, one of the swells being located along the north leg of Pi Contento. This swell has a longitudinal slope of 2% and with side slopes of 4 to 1. This swell will cover both the on-site and off-site runoff. Our second swell is located along the south leg of Pi Contento. This also has a 4 to 1 slope and a longitudinal slope of 1%. Our roadway interferes with part of the existing swell, so we will have to regrade and add rock protection to the swell. And because our swells have a longitudinal slope of greater than 1%, we need to add grouted rock protection, which will account for the erosion, which may affect the slope shape over time.
So, due to our offsite water going into the southwest side of a roundabout, we included a 2 by 2 size box culvert. And here, the water will be carried off into the north leg of Pi Contento, where it will be led into our main swale, where the water will be infiltrated. So here, using the rational method, we calculated our 100-year storm runoff to be about less than 2 cubic feet per second. And for our flow-by inlets, we used the Weir equation because the depth of our water coming into the inlet would be less than the curve opening height. As for our sump inlet, since it is at a low point, we'll be using the orifice equation because it will be accounting for when the water is over the curve opening height of our inlets. So here, as you can see, both our flow-by and sump conditions have complied with the Riverside County the minimum standards, which is 4 feet by 3.5 feet for all of them. And although environmental impact was not a part of our project scope, we took a little step into it, and we wanted to ensure whether there would be any significant environmental constraints within our project. So using the U.S. Fish and Wildlife Service website, we used their IPAC application, also known as Information for Planning and Conservation. Here, we were able to determine whether there would be any endangered species or plants within our project site. So as we located it, we determined that although there are only a few endangered species, none of their critical habitats were actually found within our project. Therefore, during the construction, we wouldn't be encountering any crucial impacts upon their homes. And now on to Michael for Alex.
So the goal of maintenance of traffic is to keep the existing road open as long as possible to limit the traffic impacts caused by construction. To do this, we divide the construction into 3 phases. However, prior to construction, electrical poles need to be moved before construction can begin. So we're giving Edison about a year to complete this whole construction. So for phase 1, this is the construction of the south and east legs, which will take about 25 working days from 6 a.m. to 6 p.m. The construction will begin with excavation of cut material from these legs that can be used as fill material for phase 1B. Now phase 1B is the bulk of the construction, which will be about 50 working days. This is the construction of the roundabout circle along with the west and north legs. For phase 2, this is when the legs will connect with the existing road, the south and east legs will connect with the roundabout, and and signing and strapping will be done as well. Once these connections and signing and strapping are complete, phase 2 can begin and the roundabout can be built in. This will take about 14 working days. For phase 3, this is the construction of the swells and the demolishing of the whole road. Now, for phase 2, it's done overnight construction, which will have road closures, as you can see on Rancho California and Consenso. Cars going along Rancho California can take a detour path in orange with a detour path of 9 minutes, and cars going along Consenso can have a detour path on this blue path for 7 minutes. The detour paths will be provided using portable changing message signs and other detour signs too. The expected working length for this project is 100 working days. Now, Joseph for
All right, I'm going to talk to you about the cost estimation and specifications for this project. Just getting right to it, our preliminary cost estimate came out to be about $7.4 million, which was extremely high for a couple reasons. If you remember, Brian earlier mentioned our first iteration of design had large sweeping curves, and that caused us to, we needed 380,000 square feet of right-of-way, and that cost $4.5 million at the price we thought. So, yeah, that caused us to redesign, and with our second design iteration, with the tighter curves in there, that saved a lot of right-of-way acquisition, and we didn't have to demo as much road either. So just that design shaved almost like $3 million off the project, but it was still really high at $4.5 million, so we decided to look into some better price references. What we ended up using was the Anza Road roundabout bid, which is the intersection adjacent to ours, the Green River Road widening bid in Pomona, and Riverside County Transportation Department construction cost worksheet. We decided to use these price references because they were somewhat local and of the same magnitude of what we expected our cost to be. So with those, we got our construction costs, line items in order. We kind of got a lot better costs for construction. We reduced the price roadway construction to $636,000, and for drainage, that came out to about $186,000. So with all that said, the cost estimate on our 7th iteration came out to $3.9 million, which was still really high, I thought. So we decided to look into the big ticket items on here, which is still right-of-way acquisition and utility relocation. So with that, for the right-of-way, we were using a methodology similar to what Riverside County Transportation Commission used for selling back unused land, unused right-of-way. If we were able to do this, it could save our project up to $1.8 million. Also for the utility relocation, CPUC, or California Public Utility Commission, Title 20A, states that utility relocation can be paid for by the taxpayers if the project site meets any of the following 4 criteria. And we felt that our project met 2 of the criteria, being Rancho Cal was a major collector road in a government's local plan, and we felt that the wine country area was kind of a recreational or scenic area. So given that, if we are able to get those innovations to work for our cost estimate, the final price would be $1.58 million, which felt a little bit better. So we prepared a set of specifications for our project using the Green Book for Public Works Construction as a base. We have special line items for everything that we use in our project. And here you can see an example for the splitter ramp with its corresponding specification and payment clause. We also prepared a website. If any of you guys are interested in looking at our project, seeing what we did, you visit cppconsulting.net.
And finally, we'd just like to thank our advisors, Jonathan Hofer at LA County Metro and Gianfranco Lori of the City of Palm Springs, and then of course all of the consultants and agencies that helped our project become what it is today. Thank you for your time. We'll now answer any questions you might have.
So one of your innovations is to sell back right away to wineries?
Yes, we believe it's in the interest of the wineries to acquire more of the agricultural land so that they can enlarge their production.
So then, did you verify that the right-of-way is actually owned and fee by the agency? 'Cause otherwise they couldn't sell it back.
We did not verify that, but that's why we were using a methodology similar to that of the Riverside County Transportation Commission. So that's the idea we had in mind.
Okay, well, I mean, some things to think about is they have to own it in fee in first place. Most right-of-way is actually considered an easement. It's a special type of easement. So you wouldn't be able to sell back something that would automatically go back to the underlying ownership. And then obviously they go through and I'm not sure about the methodology used by RCTC, but they would do an appraisal of the property to determine the actual price that would go back, which would be fair market value. And again, most agencies aren't in the business of selling back property. There, there's obviously land swaps, and a project like this, you can see something like that, it would help to benefit the wineries, otherwise it becomes a maintenance issue for the city.
That it? All right. Brian, you said that raising the profile 11 and then another iteration looked at 5 feet was, unreasonable. What made it unreasonable for you to mind raising the profile like that?
Well, especially the first one. I think we ran a really quick.
Yeah, we did a cost estimation for the 11 foot, raising the 11 feet. And
It was really
yeah,
cost.
just the earthwork was like around $5 million for the.
And then you're gonna either have to construct retaining walls or else buy more right away.
Okay.
That would have added to the cost. And also from a phasing perspective, how do you build that? You'd have to, our MOT plan works fairly well with keeping normal traffic patterns.
Yeah.
But with that, you'd have to have a detour for 6 months or something.
Yeah, good answer. Did you consider isolating any turning movements with your final design? So the way your design works is it's kind of like an offset intersection away from the traditional intersection. So you have some potential to have some like isolated right turn movements. Did you guys consider that at all?
Yes, we did consider isolated slip lanes for the right turns. However, the right turn volumes were very low, less than 5% of the total turning movement counts. So we felt that would just be not warranted for the intersection.
Oh, okay.
You give a bicyclist the option to exit the roadway or to dismount or to continue through. Did you make any special accommodations for them to exit the roadway?
Yes, I can take that question. Yeah, we have a rolled-up curb. I'm not sure if it was clear on the plans. We have a rolled-up curb a few feet before the intersection, and that comes together with the sign that we have created and still to be approved. So that gives the cyclist the option to either dismount and take a rolled-up curb and go through the crosswalk just like pedestrian would, or the cyclist would have the option to just merge into the car lane and go through the roundabout as a car.
And then did you consider adding yield lines to discourage motorists from waiting inside, hanging into the circulating roadway?
I'm not.
Yeah, that
So your MUTC detail shows the optional yield triangles. If you look at your final percent on that, so motorists may be inclined to pull it forward to the detail 40 that outlines the edge of the circulating roadway.
Oh no, we follow the MUTCD standards, and on our design, there is room for the car to stop and yield before getting to intersection. So there's enough room after the crosswalk for a full vehicle to be stopped there, yielding without interfering with the cars going through the intersection.
We do have the yield sign and the yield pin on the ground. As
But
well as the,
you omit the yield line.
yes, we can add that. We do that as well.
Do the team consider the physical impair pedestrian crossing roundabout? Right now we have single line intersection that's audible with the sound, and a lot of impaired people who use sound as a guide when the traffic stops and they go past. So not since the roundabout is moving, how do we mitigate that from using impair?
The splitter Island were designed so that the ADA ramps in the Splitter Islands, they would accommodate approximately one vehicle. I believe it's 25 feet in length from the yield line to the ADA ramp, so that when the driver approaches the intersection, they watch for crossing pedestrians, then they cross the ADA ramp or the crosswalk, and then they can yield to the intersections of the circulating roadway. We followed ADA standards for the ADA ramps, but we did not include any pedestrian signals, the like push button signals for the.
It's wine country. There's very, especially at this intersection. At AMSA, they had a little bit. You could see where it would be a little bit more pedestrians, but at this intersection, nobody's walking.
So are there any sidewalks around the area?
No.
We have sidewalks around the circulating roadway, but in between intersections, there's just a mixed-use path for equestrians, bicyclists, and pedestrians.
But if you sell the right way back, and you go to the winery right there, then Duluth's gonna get out of here.
What is the city or the county master plan? Is it all to use agricultural property?
Yes, and that is further identified in the one picture plan.
On your eyes, did you evaluate a signalized intersection? How did it compare with the roundabout?
It provided a little bit worse level of service, but still going by the county and Wine Country Community Plan requirements, it was satisfactory. However, we just mainly use it as an alternative analysis for the intersections in the case that the Wine Country Community Plan's vision for roundabouts did not work at one of the intersections for any reason.
You said the posted speed limit is 55 on Rancho. What is the side street speed limit?
Calle Contento is 40 miles an hour.
40 miles an hour. So they all have to slow down to 25 or even stop and then yield. Whereas if you put a signal, they just keep going through the speeds if they signal correctly, right? But the big thing is, what was it, the wine country? Community plan, they want around that.
Yes. All of the study intersections that we identified in the traffic impact study, they are all planned for roundabouts within the near future.
How far do you shift the roundabout to the open street? What is my
Center to center of intersections, it's about 100 feet.
How long do that project?
What's the distance? It's like 700, 800 feet from the intersection to where it connects to the existing road, you're saying?
Right.
It's about 800 feet. It varies in some of the curves there too.
What the name of the place is?
On the approach legs,
On when started back.
I designed the approach, the radii as they come off of Rancho California Road, they're at 400 feet, I believe. I designed it so that it would meet 50 miles an hour at the first radius coming off of the existing road, and then it's a compound curve coming in, and I brought the radius down.
So you check this elevation of the present?
No, because we have the signing to warn people to slow down, and super elevation encourages drivers to go. It can encourage drivers to go faster. That's why, for example, the circulatory road roundabout itself is sloped outwards. We don't want it to slope inwards because then people will use it as a racetrack. So we tried to ease the transition of the radii so that vehicles would have time to slow down without using super elevation as well.
Okay. So since this one is the case in the garage, you guys running the water for the pipework excavation between the road?
We did? Yes, I created a design service for main roads. sections and all, but yeah.
The question on the roundabout, if you go to the graphic maybe on that. Single lane roundabout, right?
Yes. Do you want the table in CHRP or?
The graphic on the
And the purple is the one to show me.
On this one, right?
Sure. So that shaded area in the center, that's the shoulder, is that correct? That one doesn't show.
That is a truck apron.
The truck apron, okay. How wide is that? 8 foot, okay. Let me ask you this, there's cars in the roundabout for this function, correct?
Yes.
Now, suddenly, from one direction comes an ambulance or a fire truck. What do traffic in the roundabout do? Not what you think they'll do, but what will they do?
Instinct is to stop.
Stop, okay. So, the fire truck gets there, and the vehicle stops in the roundabout. Is there enough room for the fire truck to go around it?
circulatory roadway is 20 feet. And then, yeah, I think actually the truck apron is 10 feet.
So you have adequate room?
Really big truck.
30 foot of width, which you need to get a fire truck through there, and the vehicle stops and the roundabout, because they think that's what they're supposed to do. But you think they can get through it? You think the fire truck can get through it? I'm just asking.
Were there any BMP requirements for drainage? For the county?
Oh, although it wasn't in our scope, we know that we have to do that, especially for this width. We know that our site is more than 4 acres, so we know we have to create other plans like that, but since it's not in our scope, we didn't.
A little more on the truck apron. Do you have any sort of curved face between the truck apron and the road?
There is a, I forget the exact dimension.
Riverside County Standard, I believe it's a rolled curve between the roadway and the higher strength concrete truck apron, just to kind of signify the difference between the two. And then the truck apron will be stamped and colored to differentiate between the two.
And is your circle still tilted, or is it flat?
It's flat. It's a standard roundabout.
I seem to recall practitioners noting that trucks are tipping in some of these roundabouts. Did you guys look at that at all?
Everything is, we didn't analyze that specifically, but everything is 2% away, which is the standard roadway across the.
Quick question, is your alien traffic, are they weekdays, weekends?
We have counts for both the weekend and weekday. However, the weekend were significantly higher because that's when the wineries get the most traffic. So we ended up using the weekend primarily for our analysis, just to accommodate that higher traffic.
When you did your comparison between the alternatives like citrus and exception, did you use citrus for proprietary level of service calculations, or did you use the highway capacity?
We use the highway capacity.
Your first numbers on traffic, you said you had 2 different models, and there was some drastic differences between the turning movements there.
One of the tables signifies the existing conditions, while the other signifies the project conditions. On the left are the existing. This is what you're talking
No,
about.
part of that, one of the first graphics you showed us. This one here.
Oh, yeah. The results weren't drastically different. However, the iterative method did provide higher traffic, which didn't account for the in the traffic impact or traffic analysis zone identified in the White Church Community Plan. They account for trips between inside the same zone, which the iterative method doesn't account for. So the traffic was assumed to be higher. However, we did use the White Church Community Plan's
seeing like, from west, it says right turn at 19, isn't that, or 29? And down here it says 185, that's a pretty big difference.
Yeah, that's why we didn't end up using the iterative method.
So which one did you use, the top of the bottom?
Oh no, this is all the iterative method where the input is on the top with the blue and orange, and then the output is in green.
Oh, I'm
So,
sorry, okay.
yeah, the one country community plan values aren't shown, but they are, as I said earlier, the right turn movements are only, they maintain the existing characteristic of, for example, the 19 out of 696, where it's less than 5% of the turning movement counts a right turn.
So,
So, is it over designed or under designed? I'm not following it. Is it over designed or under designed? Is it, let me say it better. Is it conservative or is it close to the best?
I believe it's conservative for the one country community plan. The iterative method we looked at just to have an alternative to the one country community plan, but the results were two different indeterminate accounts.
So it'll definitely work on the weekends when you have heavy traffic. It'll be fine for
Yes.
Yes, I'm curious on stage 2 of construction staging. Can you describe to me the work that's going on? Next one.
So this is where all the connect together, and we're gonna do 5-9 closer. Because most of the wiring is open from 10 to 7 p.m. So we're gonna do a closer time from 8 p.m. to 8 a.m. It's the 12-hour closing.
So my question is, the first night we close the road, you're gonna, I assume you obliterate the existing road surface. How do you open it up the next morning?
We would have to account for a full day.
We didn't. Yeah, we're gonna put the payment down and then get it it's open next month.
Because we didn't put the curves in. We have this on the curve. We tied it with existing, that way it matches the payments. And then we have to put the back roll. The curves along it.
Well, in phase 1, you've built everything you can build without touching the road. Phase 2, by definition, touches the existing road surface. So, I guess I'm not seeing how you would open it up the next day.
I think our initial idea was to have overnight closures. But I think we changed that. So it's the 5 days, the full 5 days closure.
Oh, well, that makes more
Yeah.
sense.
Yeah.
With the deeper.
Yes.
What's the total duration for the project?
It's about average about 100 working days.
Working days? Not counting the utility.
Not counting the utility. Not counting the
So you use multiple analysis software for the compound. Why do you choose the Senior software? How does it work?
Sidra intersection primarily uses the highway capacity manual for methodology, whereas Synchro you have to specify. We used SimTraffic, which is Synchro's modeling program, to run a simulation and then use those delays with the highway capacity manual. And then Rodel, the program based out of the United Kingdom, uses a different methodology, which we were curious to see the results between the two. The results between Sidra and Synchro were fairly close, and then Rodel was kind of iffy. We didn't end up using Rodel's levels of service or delays in our analysis. We just used the program and kind of see what it gets.
What's one last question? Did you price out signalized intersection? Okay, but you seemed really worried about how the cost is. I was curious if you could compare it.
We never got far enough. Oh, my. Yeah.
One thing you might be able to tell, I'm biased against roundabouts. Probably because I've been working against it for 32 years now. But you very excellent job making your presentation, and you really did a good job altogether. So very, very good. Congratulations to you all.
Any more questions? So can I ask you, so why are you biased against round design?
I probably shouldn't say because there might be some reporting. Basically, it's a wrong solution to a problem. It's trying to lessen the severity of accident. Like saying, okay, we won't have T-bone collisions anymore, because we'll just have a side swipe or this instead. I think there just needs to be better understanding of traffic flow, because this will slow down traffic on the corridor. And there will be some inherent problems with it. It won't keep people moving from point to point. It's a good idea for safety, but I think there's other solutions. And again, I think in this one, if you price it out, signalized intersection would probably do a better job. Also, there's the issue of driver frustration. You can get around, there's nobody there, but you still have to slow down and go through it. So during the week, I can see a lot of people complaining about this. On the weekend, they say, oh, this is great, this is really good. But during the week, I can put it off. But as you said, the wine country community plan, they want to have roundabouts, correct? You kind of stuck with what the client wants.
The reason for the alternative analysis was to kind of provide an option if the roundabouts don't work. So yeah, the roundabouts work. They were primary concern.
So that concludes our program. So if you have the assessment, you submit them to me, and then there are programs here. There are actually more activities.